So we are talking about using statistical software and summarizing data, and this specific section is about summarizing quantitative and categorical data, and it is one of the most important sections of this whole series of lecture, in which we're going to talk about the measures of the center of data and central tendency. We're also going to talk about measures of variability, and we're also going to talk about choosing a summary measure which is suitable for your analysis and data. So let's start off with summarizing data. Why do we summarize the data? So for data quality monitoring, checking if the data is collected in a right manner and making sure that data is complete and we do not have any missing values. We also summarize the data for data checking to make sure that the data that has been collected or entered in a program is all right, and this process is also sometimes called as data cleaning. The two most important aspects, in my opinion, is first of all baseline data. Now, summarizing the baseline data gives us a lot of information regarding the demographic information and the baseline analysis and characteristics of the participants of the research. Now, to report the basic features of the sample in a study, it is very beneficial even when you're writing a manuscript. You describe the mean age of the participants, you describe the mean weight and all the demographics and the baseline data, which is very useful and essential as well. Moreover, it also enables the researchers to interpret findings and determine the context in which the results can be applied. For example, if you're doing a pre and post analysis and you find out that there is a significant difference, so if you have mentioned the baseline data, then you can compare the follow-up data with the baseline data, and you can actually visualize that how much difference has occurred in addition to the p-values as well. Moreover, you can also perform tests of normality on the baseline data, and you can further decide that which type of test, either parametric or non-parametric and whatsoever, you're going to apply. Another very important function of summarizing the data is to use it as a precursor to more complex methods of statistical analysis, such as I gave you the example to understanding your data, that it is normally distributed or abnormally distributed or skewed, or if it has right side skewness and left side skewness, and if it is skewed or if it is not skewed, that what side of measures of central tendency should I use, what side of measures of variability should I use in interpreting and reporting my data and whatsoever, in order to interpret the results in a meaning way as well, and to be sure which methods are appropriate to be used in the first place. Descriptive summary data are needed. So that is also very important, as I already mentioned and described. Now, how can we summarize the quantitative data? So continuous data can be summarized in either a measure of the center or the measure of the central tendency of the data distribution, or a measure of the variability of the data, and almost all of the time they are both presented, mentioned, or written together. For example, mean plus minus standard deviation. So measures of the center of the data include mean, median, and sometimes mode as well. And measures of variability include standard deviation, also known as variance, range, minimum and maximum, and interquartile range. It is also important to understand that standard deviation and variance are two different terms, which are we also going to take a look in detail in the upcoming slides. So mean, what is mean? It is the simple average of all data. It is sum of all the values divided by a total number of values. For example, this figure here is very meaningful because MEAN, which actually stands for mean, but on the other hand, there are four different things. So we are adding four different characters. So we are dividing by the total number of values, which are 1, 2, 3, and 4. So that's how we calculate a mean. But we don't have to necessarily do it ourselves, because we have statistical software which can do this for us and make our lives easier as a researcher. This simple type of mean is also known as arithmetic mean, and this gives a measure of the middle of the distribution when the data follow reasonably symmetrical distribution. But that is not always the case, and sometimes the data may be skewed and abnormally distributed. So when the data are skewed, it will not represent in the middle, and arithmetic mean would not be a suitable measure of central tendency to be shared and reported. And in those cases, we can use geometric mean and harmonic mean, which actually transform the data and then present you with the mean. On the other hand, we also have median as well, which is usually presented in different type of research articles in which you would see that there is abnormal distribution of data. And it is actually the middle value when the data is arranged in ascending order of size. If there are an odd number of values in the sample, then the median will be the centralmost value, and such as if there are 9 values, then 5 would be in the center. On the other hand, if there are even number of values, then there would be 2 middle values, such as there are total number of 10 values, then 5 and 6 would be the centralmost value, and the median would be the mean of the 5 and 6, which would be 5.5. Mode, on the other hand, is the value which has the greatest frequency, and it has a limited usefulness when we're talking about the continuous data, but it is very beneficial and useful to report categorical data because it indicates the most common category and it can be useful for that. Now, those are all the measures of center or central tendency. Now, let's talk about the measure of variability, in which, first of all, we have standard deviation, and is most commonly reported with mean, and is reported when the data is normally distributed. So, it tells us how dispersed the data is. And how is it done? It is done by measure of the average difference between mean and each data value. And specifically speaking, it is calculated by taking square root of the variance. So how we actually calculate the variance in the first place, we are going to take a look at that as well. And it is often abbreviated by SD. So as we said, that it is calculated by taking a square root of the variance. So in short, the difference between standard deviation and variance is the standard deviation is the square root of the variance. But how the variance is calculated? When you talk about variance, so it is calculated by summing the squared differences between the overall mean and value for each individual or each participant, and then dividing all of those by the total number of values minus 1. So if there were 100 values, we divided by 100 minus 1, which is actually 99. The advantage of the standard deviation over the variance is that because we have taken the square in the variance, so it actually changes the unit from, for let's suppose, meter to meter square, but standard deviation takes it back to the original unit of the original data, and thus it is easier to interpret along with the mean. Range is another thing in which we can interpret the variability, and it is the difference between the smallest and the largest value in a data. For example, if we can look here, so range is actually the difference between the highest and the lowest value, which is 6 and 3. So 6 minus 3 is 3, so the range is 3. But it is usually expressed as a minimum and maximum, or the lowest or highest value, instead of just the range, which is 3, because that is more logical. So sometimes the actual difference between the two extremes is presented, but this is not a good idea as it does not show the extremes. So it is better to show the extremes as well, including the minimum and maximum values. Now, interquartile range, it is also a measure of variability, which is usually reported when we are dealing with non-parametric analysis, and we are dealing with skewed distribution and abnormal distribution of data, and it is reported with median as median plus minus interquartile. So range of values that include middle 50% of values and is bounded by the lower and upper quartile. So this is the lower quarter or the lower quartile. This is the upper quarter or upper quartile, which means 25% of the lowest values and 25% of the highest values, and the center 50% is the interquartile range. So the lower quartile is found by bracketing the data as for the median and then taking the value below which 25% of the data sits. The upper quartile is similarly the value above which the 25% of the data sits. And that is also written by the term quartile. So here you can see the interquartile range. This is the lower quarter or the lower quartile. This is the upper quarter or the upper quartile. So 25%, 25%, and this is the 50%, which is the interquartile range. And this is the median, which is also in that sense known as the 15th percentile. So first quartile and third quartile, also known as the 25th and 75th percentile. So the values between these two is known as the interquartile range. Now percentiles. We have discussed percentiles. You may not know, but we actually have. How? Because points which divide the distribution of the data into set percentages above or below a certain value are known as percentiles. And interquartiles and median is actually a type of percentiles that we have discussed about. So median and quartiles are examples of percentiles. As we already said, median is the 50th percentile, and in quartiles we have the lower first quartile, which is 25%. First quartile on here you can see 25%, third quartile on the 75%, and the largest quartile, and so on. So things like that. So median is the 15th percentile, lowest quartile is the 25th percentile, and upper quartile is the 75th percentile. Although these are the most common percentiles that we calculate, any percentile can be calculated. And for that, let's take an example here. Here we have an example that you are the fourth tallest person in a group of 20, which means 80% of people are shorter than you. So that means you are the 80th percentile of the data. And if your height is 1.85 millimeter, then the 18th percentile height is the 1.85 meter in that group. I'm sorry, I said millimeter, it's meter. Now, choosing summary measure for quantitative data. Now, we have talked about the summary measures. Now, which one would be the correct summary measure to choose? So, usually useful to present more than one summary measures for a set of data, such as central tendency and variability both, and that's how often we do it, such as mean plus minus standard deviation and median plus minus interquartile. It is good practice to report the actual number of data values as well as the summary values, and that's what happens when we analyze the data with SPSS. It gives us the N as well. N is the total number of participants. Since in general we have more confidence in greater numbers, so greater the N, greater confidence we would have in the findings. So if the data are going to be analyzed later using methods based on the means, then it makes sense to present means rather than medians, because if you're using parametric analysis and or parametric test of significance, then you should present means. If you are using non-parametric test of significance, then you should use medians. So it all depends on that as well. So if the data are skewed, they may need to be transformed before analysis. So it is best to present summaries based on the transformed data, such as geometric means instead of the arithmetic means. Now, center of distribution. So continuous data with symmetrical distribution. If we are having continuous data with symmetrical distribution, we would use arithmetic mean. If you have continuous data with positively skewed distribution, we would consider geometric mean or harmonic mean. And if we have continuous data with skewed distribution, then we would go for median. And if we have discrete data, then we would go for median. Unless the range of data is large enough to make calculation of a mean sensible, then we can go for arithmetic mean. And the example here is that the number of children in a family is discrete, and although sometimes the mean number is calculated, it may be difficult to interpret because those are small values, and if we get the mean of 2.4, now the number of children 2.4 does not make any sense. So it's better to go off with the median instead of mean. For data with narrow range, such a stage of cancer which has 4 stages 1, 2, 3, 4, it is better to present the actual frequency distribution to give a fair summary of the data rather than calculate a mean or dichotomize it, because it is categorical, so it's better to give the frequency distribution for it. Now, if you're talking about the spread of the distribution, if you have continuous data, use standard deviation, and that's why it goes off with the arithmetic mean plus minus standard deviation. Continuous data with skewed distribution, then consider using interquartile range, and it goes well with median. So median plus minus interquartile range. And if we have continuous data, then we can also present range from minimum to maximum, because it is useful if there is room to present this in addition to the standard deviation. So you can use it, but if you don't have space or if there's too much data, you can just skip that as well, but it's better if you can. Now, summarizing categorical data, that was all about the continuous and quantitative data. So we can also summarize the categorical data. And for that, it is important to know that when categorical data are coded for data analysis, with numerical codes, they cannot be considered quantitative. If I have given 1 and 2 as codes for gender, male and female, this does not mean that it is being converted into a quantitative data. So don't try to calculate the mean or median of it. So there can be unordered categories such as nominal data and ordered categories such as ordinal data. So gender is an unordered category and stages of cancer is an ordered category. We can also use cross tabulations for summarizing categorical data as well. So let's start off with unordered categories such as nominal data. So it is summarized using frequency distribution in each category together with either the overall proportion or percentages, as we can see in this graph, in this picture. Here we have the different categories: owner, council rent, private rent with parents, etc. And we have the number and we have the percentage in the bracket. So we have to mention, if you're using proportion in the bracket, we should mention it. If you're using percentage, we would mention it. So here we have total number and percentage. So choice of whether to use appropriate to use proportions or percentages. Here we have used percentages. Although in research articles, it is more common that I've seen that there is more commonly percentages have been mentioned instead of proportions. The complete set of frequencies is the frequency distribution. So this complete table is known as a frequency distribution for housing. Now, ordered categories, such as I gave you the example of stages of cancer, like stage 1, stage 2, stage 3, and stage 4. So it can be summarized once again by frequency distribution and along with percentages. So here we can also calculate cumulative frequencies and percentages, which makes sense if it is an ordered category, such as here we have professional, managerial, skilled, non-manual, skilled, manual, semi-skilled, manual, and unskilled. So here we have frequency, here we have percentage, and here we have cumulative frequency, and here we have cumulative percentage. What's the benefit of cumulative percentage? I can here say that 45% of the participants in terms of their occupational classification were employed in non-manual. So that is the benefit of mentioning cumulative frequency. So it can be useful to show the percentage below a certain cutoff, like for example, this is non-manual and moving on from here, there are manual and unskilled. Now, cross tabulations. Cross tabulations is another way to present categorical data and often useful to tabulate one categorical variable against another. For example, here we have cancer type, which is one variable and one categorical variable, and I have tabulated it with another categorical variable, which is gender and male and female. So it is giving me percentages and frequency distribution for all the participants, but also dividing them on the basis of male and female and as well as total. So it's very interesting. So it shows proportions or percentage of categories of one variable by the other, and that was all about this section of the lecture. I hope you learned something new out of it. Thank you very much for watching sqadia.com.